Hello again, welcome to another video, Permutations and Combinations, more examples. So to start with, we have a boat that has 4 seats on each side and we want to arrange 6 buoys. This is a permutation as the order matters. It's the same as saying 8p6. Here's the equation for permutations and it's relatively straightforward. You have 8 places, 8 factorial, and you divide it by 8 takes 6 factorial, giving 20,160. In part B, we have to work out in how many ways they can sit, but we're given that buoy A and buoy B are sitting on the port side and buoy C is sitting on the starboard side. So again, it's a permutation, but this time we have 4p2 because we are choosing 2 buoys to sit in the 4 seats on the port side, times by 4p1 because we're only choosing 1 buoy to sit on the starboard side, and then we have to times that by 5p3 because there are 5 seats left and we have 3 buoys we still have to put in those seats. So putting the relevant numbers in the equations, we end up with this. And if we write it like this, it makes it easier to cancel out. So the 2 3 factorials cancel out. These 2 factorials cancel out. These 2 factorials cancel out. And we're left with 12 times 12 times 20, which is 2,880. In the next question, we're asked, if we only have the digits 2, 3, 4, 5, and 6, how many numbers can we make that are greater than 4,000? Well, if we use 5 digits, all of the solutions are going to be over 4,000. And this is the same as writing 5p5 or 5 factorial. And there's 120 different answers. But what if we only use 4 digits? Well, then only the solutions that start with 4, 5, or 6 are going to be greater than 4,000. So if we write it down like this, we have a choice of 4, 5, or 6 for the first place. But then for the second place, we'll have 4 choices. For the third place, 3 choices. And for the fourth place, 2 choices. So the answer is 3 times 4 times 3 times 2, which gives 72 different solutions. If you prefer to use the equations, you can work it out that way, and it would be 3p1 times by 4p3. And if you work it out, you see you also get 72. Any number using 3 digits is going to be under 4,000. Therefore, all the solutions over 4,000 is equal to 120 plus 72, which is 192. In part B, it asks how many 4-digit numbers would be even. Well, only the numbers that end in 2, 4, or 6 are going to be even. So for the last digit of the 4 numbers, we can write 3p1. And then we have 4 choices for the first number, 3 for the second, and 2 for the third. So again, you can work it out the logical way using 4 times 3 times 2 times 3, because 3p1 is 3. Or you can work it out using the calculation, which is 4p3 times 3p1. And the answer is 72 again. Next, we're going to look at circular arrangements. If you have A, B, C, D, E around a table, you need to be aware that all of these permutations below are exactly the same because there is effectively no beginning and no end. So the way we tackle these problems is by fixing the position of one object, and then we organise the remaining objects, which is n take 1, as if they're in a straight line. So in how many ways can these 5 people be seated around a table? Well, let's fix Alice in the top position. And just as we have with a straight line, we'll have 4 choices for the next position, 3 for the next, and so on, giving 4p4 or 4 factorial, which is 24. In the next question, we have to work out how many ways you can organise 6 men and 6 women around a table. So as we just mentioned, the first thing we do is put a person in one of the seats at the table. This means that we've only got 11 people to organise in the next 11 seats. So the answer is 11p11, which is 11 factorial. But in how many ways can you organise them if the men and the women need to alternate? Well, we still need to put one person on the table to start with, so we've chosen the woman. So the person who goes next to her will have to be a man. And there are 6 men to choose from, so we can choose that position in 6 ways. But then the person next to him has to be a woman, and we only have 5 women to choose from to go in that position. And then the person after that has to be a man again, but there's only 5 men left now. So therefore, there's only 5 people to choose from for that position, and so on until we get this. And this is the same as saying 6 factorial times by 5 factorial. So the answer is 86,400. But what if Ted and Carol sit together? Well, we treat Ted and Carol as one unit, so there are 10 more people we need to seat around the table. But also Ted and Carol can be swapped, so you can have Ted and Carol or Carol and Ted. So we need to times 10 factorial by 2 factorial to get the answer. And similarly, if Bob, Ted and Carol must sit together, we treat those 3 as one group, and there are 9 more people to seat around the table. But there are also 3 factorial ways of arranging Bob, Ted and Carol within their group of 3. So the answer is 3 factorial times by 9 factorial. Now, if neither Bob nor Carol can sit next to Ted, let's first of all put Ted at the top of the table, and then remember there are 2 spaces either side of Ted. There are 9 other people to choose from because we can't choose Bob or Carol and Ted's already at the table. So that is 9p2. And when we've chosen those 2 people, there are 9 remaining seats and 9 remaining people to fill them. So that's 9 factorial. So the final answer is 9p2 times by 9 factorial. Unfortunately, I've gone on longer than I expected, so I'm going to go through the last question really quickly. There are 8 beads and you need to put them on a necklace. So you fix 1 bead, which means there are 7 factorial ways of arranging the rest of the beads. However, the necklace can be turned over, which means that if you have blue, green, pink going clockwise, and then you flip it over and you have blue, green, pink going anti-clockwise, these are the same. Therefore, you have to divide the answer by 2. So the final answer is 7 factorial divided by 2. Thanks very much for watching. I really hope it helped. As always, I'd really appreciate it if you liked it and subscribed. Thanks very much. See you soon.